Okay, so in this video I'm going over test number 3. It's now a practice test. This was from the fall of 2018. So we'll go through the multiple choice questions first, and then after that the free response. So here we go. Right, so some of them are pretty straightforward. The first question, the value set for alpha is known as, so we just write our choice here. This one, every test has a gimme or two. This should be the significance level, so that's C. All right, that's just a fact, so no explanation required. Number two studies are run to compare the experiences of families living in high-rise apartment houses, high-rise public houses, to those families living in townhouse subsidized rentals. First study interviews 25 families who have been in each government program for at least 1 year, while a second randomly assigns 25 families to each program and interviews them after 1 year. Which of the following is a true statement? All right. So it's basically a question of whether or not they're experiments. All right. So the idea here is is there a treatment imposed? All right. So in the case of the second group, the second randomly assigns 25 families to each program and interviews them after 1 year. All right. So you have the two possibilities. You have the high-rise public housing, and then you have the townhouse subsidized rentals. The fact that they're randomly being assigned those 25 families to each program and then interviewed, that's a treatment being imposed. In the first group, those individuals have been in each government program for at least a year. We had no control over that. We did not assign them to be anywhere. So the first one is an observational study, and the second one is an experiment. All right. So, choice C. Number 3, which among the following is most useful in establishing a cause and effect relationship? Well, we know from the notes and just from everyday experiences that things like anecdotal evidence or just correlations between two variables aren't always going to give you a cause and effect. Like, for example, height and weight. Does an increase in weight cause an increase in height? Right? I'm sure that would be a wonderful thing. Yeah, I put on an extra 20 pounds over the winter. It stinks, but fortunately I gained 6 inches in height to accommodate it. It doesn't work that way. The other way around might be all right, but not in all cases. Right? So just having observations isn't necessarily going to establish cause and effect relationship. The only way to do that, the only way to establish cause and effect is with a controlled experiment. All right. Smaller p-values indicate more evidence in support of meh. So we know that if the p-value is less than the alpha value, we reject the null hypothesis. All right, so a small p-value, sufficiently small. If I have a choice between HO and HA, a small p-value is going to reject the HO, which means that the HA would be true. All right, so a small p-value, smaller p-values would be support of the alternative hypothesis. All right, C and D didn't make any sense because the idea is that we're either going to support one or the other of the two hypotheses. Quality of the researcher, further testing, those aren't hypotheses. So there we go. Number 5, the null hypothesis usually represents the status quo. Status quo. That came out directly out of the notes. That's talking about the idea that it's some long-standing rule or belief. All right. preconceived ideas of the researcher, that can work its way into why the study was conducted to begin with. Same thing with the theory the researcher would like to prove and perceptions of the sample population. Anything involving like ideas from individuals, that might be the genesis of the study to begin with, but it doesn't necessarily represent a particular hypothesis in all cases. The null and alternative hypotheses divide all possibilities into, well, it's one or the other, right? So those sets wouldn't overlap. You're looking at a set of, we have the entire sample space. We have one set that makes up the HO, another set that makes up the HA, and then we have everything else, which is all the stuff that we don't care about. But these are the two possibilities that we're looking at. So two non-overlapping sets. And it's definitely two sets. So the one where it says as many sets as necessary to cover all possibilities, that would be nice, but that could be a lot. It's like, if you ask the teacher a question, how can I get an A in this class? And you say, okay, there's about 1,000 different ways you can do that. And then they start listing all of them. You're like, okay, that is of absolutely no help. You got to narrow it down for me. Like give me 3 things, give me 2 things, So that's kind of the idea here. All right, so 2 non-overlapping sets. So B, if my pen decides to work. Type 2 error. Well, we got 2 types of error. Type 1 is when we incorrectly reject the null. All right, so, and I'll make a note of that here, because that's a possible question. So type 1, incorrectly reject the null. All right, so anything that says anything about incorrectly rejecting the null would be eliminated. We could also drop C and D, because that's not talking about anything related to the null or alternative hypotheses. Type 2, and I'll write it out here, but incorrectly you can look at this 2 ways. Incorrectly reject the alternative, but we don't typically talk about the alternative in terms of rejection. Incorrectly fail to reject the null hypothesis. All right. So choice B is the case of the type 1 error. Choice A is the case of the type 2 error. All right. So what that means is, and the one that's more egregious, the one that's more serious, is type 1, because, and that's what I'm kind of alluding to here, is that the type 1 is when you're taking that long-standing rule or belief and dismissing it based off of the conclusions of your study. All right. I look at it, and most people do too, as, well, you better be right. Right? The type 2 error, while still bad, isn't as bad, because if there's a long-standing rule or belief and your data incorrectly tells you to conclude that long-standing rule or belief is correct, then you're not changing wholesale policies, government, whether it's in the federal, local, or hyper local levels, but it depends on what that long-standing rule or belief is, because if you're trying to affect change of something that's really, really not good, like, for example, a certain segment of the population not being allowed to vote, like, for example, women's suffrage, like, women not allowed to vote. That was a long-standing rule or belief. A type 2 error we would say we're accidentally keeping that rule in place. There's a good segment of the population to be saying that's a whole lot worse than a type 1 situation, where even though the data doesn't suggest it, if we toss that as a rule, we say, okay, let's get rid of the rule where women cannot vote and allow them to vote. And it turned out that we were wrong about that. I don't know too many people who are losing sleep over that. Well, unless somebody lost their seat in the Senate because, of something along those lines. But, there's no right answer when it comes to statistics, because there's always a person who can come up with a counter argument. And it's usually driven by motivation. Number 9 is kind of a repeat question, but, the values, kind of a repeat question. It's exactly a repeat question. It's an important one. The value set for alpha is known as the significance level. Apparently number 10. Oh, this was a great test for me, apparently. Smaller p-values indicate more evidence in support of the alternative hypothesis. Yet another repeat question. Apparently this semester, 2018 fall, I really wanted to drive these 2 particular points home. Actually, no. I just hit copy-paste way too many times. Which of the following is not typically used for alpha? That would be the 0.25. That's because 0.01, 0.05, and 0.10 are the most commonly used ones for alpha. Which of the following is a key distinction between well-designed experiments and observational studies? All right. We kind of already addressed this question already. Addressed it already. A couple of alreadys in that sentence already. So, the cause and effect. That's what we're looking for when we design an experiment. All right. And so if we can get that, then we've done our job. And that's what distinguishes it from an observational study. Manufacturer of balloons claims that P, the proportion of its balloons that burst when inflated to a diameter of up to 12 inches, is no more than 0.05. Some customers have complained that the balloons are bursting more frequently than 0.05. Okay. The alternative hypothesis, null hypotheses always involve equal signs, so get rid of that one. The alternative hypothesis never involves an equal sign, so definitely get rid of A. So when you're looking at your choices, it's greater than, less than, or not equal, because we're talking about the claim being that they burst more frequently than the 0.05. It has to be choice B. Number 14, a volunteer for a mayoral candidate's campaign periodically conducts polls to estimate the proportion of the people in the city. You know what? I'll take it as a typo. Let's say proportion of the people in the population of the city, just so we have alliteration. I feel like I was just kind of having a little bit of fun reading that sentence, and I'd like to have more fun, because periodically conducts a poll to estimate the proportion of people in the population of the city planning to vote on this candidate in the upcoming election, 2 weeks before the election. The volunteer plans to double the sample size in the polls. Double the sample size in the polls. Which of the following would be the best reason for why the volunteer would do this? Reduce non-response bias. Well, more people in the sample, less people to not respond. Reduce the effect of confounding variables. Confounding variables, those would apply for experiments. This appears to be an observational study. Reduce bias due to the interviewer effect. All right. So interviewer effect is not something that we've dealt with at any point in this course. It's kind of like the white coat effect, along the lines of, when you get your blood pressure taken in a doctor's office, the lab coat, the white coat. It shows, studies have shown that there is an increase in blood pressure, heart rate due to the fact that an individual is getting tested, right? Getting their blood taken or getting their blood pressure taken. And so the interviewer effect has a kind of a similar outcome. People react differently when they have to answer questions posed by another human being. All right. If I double a sample size, I mean, unless they're changing how these individuals are going to be polled, I don't see how this would apply. Reduce variability in the population. Well, I don't know that we have control over the variability in the population, or decrease the variability in the population. If it said decrease the variability in the sample, sure, because then you'd have a bigger sample. And then with the central limit theorem, you can use that to, come up with less variation within your samples. But we have no control over the population. You can poll like 100 times instead of double the sample size, 100 times your original sample size, and it's still not going to change any aspect about the population. It might change your understanding of the population, but it's not going to decrease the variability in the population. So the best answer here is A, because if you poll more people, there's less people that you have to worry. Well, I was going to say there are more people that will more people that are going to participate in your study. I was originally going to say that there are less people to say no. Well, no, you poll more people, there are going to be a lot more people that can potentially say no. All right? Maybe when you double it, you just get a lot of contrarians. But you're increasing the chances of getting whatever number of individuals to be part of your study that you are targeting. All right, so I got it out eventually. It happens. Okay, moving on. The manager of a factory wants to compare the mean number of units assembled. Mean. All right, so I'm not going to read anything else yet. All right, means have to do with t-tests, not prop tests. All right, 200 employees from the factory are randomly selected, and each is randomly assigned to one of the two techniques. After teaching 100 employees one technique and 100 employees the other technique, so that sounds like 100 individuals per sample, and those are independent samples. So 100 individuals in two independent samples. The fact that there are two means that it's not going to be, unless it's matched pairs, it's not going to be a t-test. This is a two-sample t-test. We're comparing the mean values between two independent samples. The key is they're independent of one another. All right. So I'm going to end this